In this video, we'll be going over the percent error formula, which is actually right here at the top. Percent error is the measured value minus the accepted value divided by the accepted value times 100. Hopefully, if you remember the math we did at the very beginning of the year, this was the very first formula we went over. I just didn't put any numbers or science to it. Percent error can be negative or positive. The negative number means that the measured value was below the accepted value, so you measured too low. And the positive, if you get a positive percent error, then your measured value was bigger than your accepted value by that percent. So if the percent was negative 10%, that means you measured 10% too low. And if it was positive 10%, that means you measured 10% too high. Another word for measured is experimental, because we measure things in experiments. And another word for accepted is the known value, because the accepted value is what everybody knows is the correct value. So that's why it also can be called those names. They can be used interchangeably. So let's do some problems. Just like in our density formula, we are going to write a skeleton out. I like to do it like this. Percent error equals m minus a over a times 100. That way, I don't confuse the m and the a, the measured and the accepted. That is the number one mistake I see with students, is they'll put the measured, especially on this numerator, they'll put the measured and the accepted in the wrong spots, and then they'll do the answer, and then they'll complain or wonder why that I got a positive answer and then their sign was the opposite of my answer. So if I got positive, they get negative. If I get negative, they get positive. And so it will be it can be very deceiving, because it'll look like the right answer, but the sign might be wrong. And if the sign's wrong, then the problem's not right. So let's go over this first one. A student determined the density of water to be this. So notice, student determined. So that means the student did it. It's the measured value. So 0.977. I'm not worried about writing in the units every time for this problem. What is the percent error? So that's what they want. So that's my x. And then they tell me the known density is 1.0. So that's the accepted. So my first step with this problem is going to be, just like in the math sheet, is going to be to distribute the 100. So I'm going to get this. Okay, I shortened things up. I turned the 1.0 just into 1. I distribute the 100. Now for this problem, it's actually super easy. Since x is already alone, we can just do this and subtract those two, divide by 1, and then your math's going to end up being negative 2.3%. So that's a very, very easy percent error problem. The next one will get a little harder, and then the third one will be the hardest version. And then after that, you will have seen every version of percent error that can ever be given to you, because there's only 3 variables in the whole equation, and therefore there's only 3 places they can place the x. So number 2, the percent error was -7. The accepted value is this. Now, if you notice, we're talking about the heat of fusion. Now, I did this intentionally. You don't know, or you most likely do not know, what the heat of fusion is. It's a concept that you typically learn in chemistry, and you haven't learned it yet, so therefore you don't really know what it is. The reason I did that is simple. Even if you don't know what the problem is, you can still do, or you don't understand the concept, you can still do a percent error problem, because all you need to know is the value that they should have gotten, which in this case was 334 J/G.C, whatever that means. Okay, you obviously don't know what it is yet. And then you want to know, what did they get? So that would be the measured value. So let's set it up. So my accepted value is 334. My percent error is -7, and I want my measure. So I'm going to distribute my 100, and I'm going to get this. Then I'm going to make 2 fractions and cross multiply, and I'm going to get this. Then I'm going to combine like terms. So in this case, the like terms do not have an x. There are multiple ways of doing this. The most direct and easiest way is going to be to just add this to both sides. So it cancels there and it adds to the other, and we're going to end up with then I'm going to divide to get x alone, and I'm going to get x equals 310.62. The common question is, well, what units would it be? Well, here's the thing. Even if you don't understand the units, we know that the accepted value has units that were joules/g.c, and we know that we subtracted measured and accepted, right? So therefore, they have to be the same units. So even if you don't understand the units, since we're subtracting numbers, they have to be the same unit, right? So if I gave you a problem like, what's 5 pounds minus 3 feet? You can't do that problem because pounds and feet are different units. You can do 5 pounds minus 3 pounds, you can do 5 feet minus 3 feet, but if they're different units, then you can't do the math, which is something we instinctively know when we use very simple units like pounds and feet that we can relate to, but it usually tends to get lost when we try to do more complicated things, but it still holds true. So that is your answer and your units, whether you understand them or not. I obviously will explain them when we get to this unit in much more detail. And the very last problem. So in this case, they tell you that the density was determined to be 1.4. So determined, that's a way of saying they did it in an experiment. So that's your experimental. Your percent error is 23, and they want the accepted. So percent error equals m minus a over a times 100, 23. I want the accepted, and I have my measured. So my first step, distribute the 100 into the top two numbers. So I get 23 equals 140 minus 100x over x. And then I'm going to make two fractions and cross multiply. So I get 23x equals. Then I'm going to combine like terms. Since this is a negative, I'm going to add it to both sides, and I'm going to move it over here. Then to get x alone, I simply divide by 123, and I get my final answer. X equals 1.14 grams per milliliter. The units simply came from the problem. In other words, since the 1.4 had a G/ml unit, and I knew I subtracted them, same thing, I knew the units have to be the same. So that is our percent error notes. This is the only type of percent error problem you're ever going to get. Basically, there are three locations. There's the percent spot, the measured spot, and the accepted spot. And in each problem, in problem 1, I put it in the percent. In problem 2, I put it in the measured. And in problem 3, I put it in the accepted. So these examples are how you solve percent error problems, and it's every possible variation of a percent error problem you will ever get from my class. There really isn't any other variation because there's only 3 spots to put them. So that concludes this video. There will be a worksheet and an answer key available at some point in the future.